Solving inequalities are very much like solving equations, except they are a little bit different. Unlike equations, an inequality tells you what the answer could be, not what it is. To solve a one-step inequality, simply do the opposite of what is being done to the variable. In this example, add 7 to both sides of the inequality since 7 is being subtracted from x. Your answer should be x is less than 14. In this example, the coefficient is 3, so x is being multiplied by 3. We need to do the opposite, so divide both sides by 3. Your answer should be x is greater than or equal to 3. Unfortunately, when the coefficient is negative, you have to do something a little bit different. In this example, the coefficient is -4, so x is being multiplied by -4. First, divide both sides by -4. You should get x is less than or equal to -3. But here's the catch. In an inequality, when dividing by a negative coefficient, you need to flip the sign. If you flip the sign in this inequality, your final answer should be x is greater than or equal to -3. Two-step inequalities are just like solving a two-step equation, except once again, if you're dividing by a negative coefficient, you need to flip the sign. If you haven't already watched our video on how to solve two-step equations, then make sure you click the link in the description now, since you need to know how to do that in order to solve an inequality. First, add the inverse of the constant to both sides. To do this, add 7 to both sides of the inequality. You should end up with -2x is greater than or equal to 12. Now divide both sides by the coefficient. To do this, divide both sides by -2. You should end up with x is greater than or equal to -6. Remember, since the coefficient is a negative number, we need to flip the signs. Your final product should be x is less than or equal to -6. It is important to know how to graph inequalities on a number line, as you will be required to often after solving one. When graphing inequalities, if your inequality sign is either greater than or less than with no or equal to, you place an open dot on the number. This is to show that this number is not included in the set because equal to is not included in that sign. If your inequality sign is either greater than or equal to or less than or equal to, you place a closed dot on the number. This is to show that this number is included in the set because equal to is included in that sign. Let's say our inequality was x is greater than 5. First, place an open dot on 5. Next, draw an arrow pointing to the right. The reason we are pointing the arrow to the right is to show that all numbers that are greater than 5 are included in the set, like 6, 7, 8, 9, and 10. Let's say our inequality is x is less than or equal to -2. First, place a closed dot on -2. We are putting a closed dot, not an open dot, because -2 is included in the set. Next, draw an arrow pointing to the left. The reason we are pointing the arrow to the left is to show that all numbers that are less than -2 are included in the set, like -3, -4, -5, and -6. The last major thing to know about inequalities is how to solve them when there are variables on both sides. Solving an inequality with variables on both sides is just like solving equations with variables on both sides. To understand how to solve inequalities with variables on both sides, Click on the link in the description to see how to solve equations with variables on both sides. Basically, all you must do is get rid of the coefficient on one side of the inequality. I always get rid of the smaller coefficient. So, I'm going to have to get rid of negative 3x by adding 3x to both sides of the inequality. Now, I have a two-step inequality. I can simply solve for this, and then I am finished. Just remember, if you have a negative coefficient, you must flip the inequality sign at the end. Thanks for watching, and remember to subscribe for more math curriculum related videos.